Hello, this is Mr. Marcolini, or at the Math Whiz, and today's lesson is prime and composite numbers. If you're in the state of Virginia, that is SOL 5.3a. Right, what is a prime number? So a prime number is a natural number with exactly two factors, itself and 1. Natural numbers are your counting numbers, 1, 2, 3, etc., etc. As you see, it starts at 1. Doesn't start at 0. So your natural numbers begin at 1 and then you count forward. So starting at 1 is basically all your positive numbers. So what we're going to do here is we're going to name the factors of the numbers below. So let's go ahead and pick out this pretty green color. What are the factors of 2? I can say, well, those are 1 times 2. Factors of 3, I say, well, 1 times 3. Factors of 5, I can say 1 times 5. And factors of 7, I can say 1 times 7. What do all these have in common? Okay, well, you could say, Mr. Marcolini, as a factor, they all have in common 1 is a factor. And I would say you are correct. They also only have, each of those only have 2 factors. They have itself and they have 1. And therefore, that is what makes all of these numbers prime numbers. All they have as factors are itself and 1. And that is basically the definition of a prime number. These 4 right here, 2, 3, 5, 7, are your first 4 prime numbers. And they're very important, which we'll find out a little bit later on. So if prime numbers only have 1 in itself as factors, what do you think would be the definition of a composite factor? Of a composite number. So prime numbers only have 1 in itself as factors, so 2 factors. Therefore, a composite number would have more than 2 factors. So as we see right here, composite has more than 2 factors. And if I wanted to draw it out or build it out and wanted to make arrays, composite numbers are going to have 2 or more arrays. Prime numbers, you can only make 1 array. Now, I want to look at a little note down here. 0 and 1 are neither prime nor composite. And you need to understand that because on tests, they love to use 0, 1, and 2 in sets of numbers to throw you off. All right, so 0 and 1 are neither prime nor composite. 0 is not a natural number. Remember, we had talked about starting at 1 with the natural numbers. 0 is not part of that. That's a whole number, not a natural number. And 1 has only itself as a factor. Factors of 1, 1 times 1 is just 1. A prime number has to have 2 factors itself in addition to the number 1. All right, making arrays. How many arrays are for each number? So we're not really going to make the arrays right now. We're going to go ahead and say, okay, if I was going to make arrays, what would they look like? Well, for the number 9, I can have an array that was 1 by 9. I can also have the array kind of like a square and make it 3 times 3, or 3 by 3. For the number 10, I can say I can have a rectangle of 1 by 10. I can also have a rectangle of 2 by 5. For 11, I can have a rectangle and draw it out of 1 by 11. But that's all I can do for that one. And then for 12, we can have 1 by 12. I can have 2 by 6. And I can have 3 by 4. A lot of times it will help you to draw them out. So how many do we have for each number? Well, for the number 9, we have 2. For the number 10, we have 2. For the number 11, we have 1. And for the number 12, we have 3. So that makes the number 9 is a composite number because it has 2 or more. The number 10 is a composite number because it has 2 arrays. Number 11 only has 1 array, so therefore that is a prime number. And the number 12 has 3 arrays, so that would also make that a composite number. So this is a pretty easy way. If you don't memorize all your primes and composites, you can always make arrays. If you can make 2 or more arrays, it's a composite number. If you can only make 1 array, it's a prime number. But I know what you're thinking. You're saying, how do I decide if a number is prime or composite if it's a bigger number and I don't know its factors? Very good question. What do you think we could do? We could use a calculator. We can use a calculator to determine if a number is prime or composite. So what we're going to do, remember we had talked about earlier those first 4 prime numbers, 2, 3, 5, 7? Here's where they really come into and play a huge factor. So you're going to divide a number by the first 4 prime numbers, 2, 3, 5, 7. If any answer is a whole number, it's a composite number. I don't have to have all 4 to be composite, just 1. But if all 4 answers have decimals, then it's a prime number. So let's say if I had the number 15. I go 15 divided by 2 equals, I have a decimal. 15 divided by 3 equals, my answer would be 5. 5 is a whole number. Therefore, I know 15 is a composite number. So let's go ahead and see how this works. So we're going to have 3 numbers here, 27, 31, and 91. We're going to divide each of these by 2, 3, 5, 7. If you're watching this for the first time, go ahead, pause the video, and divide each of these numbers by 2, 3, 5, 7. All right. 27 divided by 2, that would be 13.5. 27 divided by 3 is 9. 9 is a whole number. Do I have to go on 5 and 7? No, I do not. I can just stop right there because since that's a whole number, I know 27 is a composite number. Now I go to 31. 31 divided by 2, 15.5. 31 divided by 3, looks like that would be 10.3. 31 divided by 5, looks like that would be 6.2. And 31 divided by 7, looks like that would be 4.4. All right, decimal, 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 decimal. All of them have decimals, so that makes 31 a prime number. Now we head over to 91. 91 divided by 2 equals 45.5. 91 divided by 3 equals 30.3. 91 divided by 5 equals 18.2. 91 divided by 7 equals 13, which is a whole number. Decimal, 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 whole number. As soon as I have one whole number, that makes 91 a composite number because its factors are 1 times 91 in addition to 7 times 13. Now, quick check. Which set below has 2 prime and 1 composite number? All right. What I want you to do, pause this, work each of them out. Take each number, divide it by 2, 3, 5, and 7, and decide which ones are prime, which ones are composite, because you are looking for 2 prime and 1 composite. All right. If you've done that, let's go ahead through. 17, that would be a prime number. 33, I can say 3 times 11, so that makes that a composite number. 54, that would be 6 times 9, so that makes that a composite number. Does that match 2 prime, 1 composite? No, it does not. 25, 5 times 5, so that makes that a composite. We know from before, 31 was a prime number. 69, 69 divided by 3. I can use my little calculator, and that is 23, so that makes that a composite number. So we come down here, 2. You say, oh, Miss Marcolini, 2 is an even number, so it's composite. Au contraire, remember, 2 is your only even prime number. So that makes this prime, 19 is prime, and 45 divided by 5 is 9, so that makes that composite. So 2 prime, 1 composite, and that makes this our answer. So, hope you enjoyed our lesson today of prime and composite numbers. This is Mr. Marcolini, signing out.